Hello, in this video, we're going to be learning how to name cycloalkanes. Now, alkanes are saturated hydrocarbons that contains carbon single carbon bonds. Now, the word cyclo means that it is in a cyclic form. So it is still an alkane, but instead of this one being in an open chain system like this, is in a cyclic form. So all the rules of naming alkanes are the same. The only difference is that we will always add cyclo in front of the parent chain. Now, also, most of the drawings are written in skeletal or line structures, which means that it's important we identify the carbons. The carbons are going to be the edges or the corners. So starting with this one, this here is a carbon, this is a carbon, this is a carbon, and also a carbon. So those corners are your carbons. So now that you've identified all your carbon atoms, you're simply going to count the number of carbon atoms that you have. So in this case, if I start counting from here, that's 1, 2, 3, 4, and then 5. Now the prefix for 5 carbon is pent. But because this is cyclo, we're going to start with cyclopent. So 5 carbon in a cyclic form. And then because this is an alkane, alkanes will just have single bonds. That will end with A, N, E. And the name of this compound will be cyclopentane. And that is it. For the second example, again, we start by identifying all our carbons, and the corners are the carbons. So this is a carbon atom, carbon, and then carbon. Now we count. For this one, because you have a substituent attached, this is chloro. So chlorine as a substituent is chloro. Iodine as a substituent is iodo. Now, in terms of the numbering or the counting, you have to count from the side that gives your branch a lower number. So you give the priority to the branches or the substituents. I'm going to start my counting from this chlorine. So that will be 1, 2, 3, 4, 5, 6, and then 7. So the name of this compound would be 1-chloro. You put the position of the chloro. And in this case, chlorine is attached to carbon 1. And then 2-iodo, the position of the iodine on carbon 2. And now we have a total of 7 carbons in a cyclic form. 7 is hept. So we're going to say cyclohept. And because this is again single bonds all round, you're going to end it with ANE. So that'll be 1-chloro, 2-iodo cycloheptane. The next one is this. As usual, we identify all the carbon chain on the cyclic form first. So the corners, as indicated with the blue dots, are the carbon parent chain. This part would be your branch this time. This is what we call an alkyl group, and you have 2 carbons attached. Okay, so these 2 carbons would be called ethyl. That is an alkyl group. So eth for 2 carbon. The YL is the ending for alkyl groups. Carbon chain branches or substituents. So we count from the side that is closest to the substituent. So this is going to be 1, 2, and then 3. We start naming from the branch. So this is going to be 1-ethyl, and then we have cyclo, and there are 3. The prefix for 3 is prop. And because this is all single bonds, you're going to end with ANE, and the name of this compound will be 1-ethyl-cyclopropane. Now, to also add, propanes are the smallest cycloalkanes. You cannot have 2 carbons, so the smallest one is 3-carbon cycloform. And for the last question I have, as usual, you identify your carbons. This is a carbon, 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 and then carbon. And then we're going to count from the side that gives your substituent a lower number. So I'm starting my counting from here. This is 1, 2, 3, 4, 5, and then 6. And the reason I started from here is that you have more things on top, so that gives you more priority than the one below. Okay. So the branches, I have 1 and 2 branches, carbon branches. Those are carbons as well. So the carbon branches for 2 is eth, and then it ends with YL. We also have the same carbon, 2 carbon branch on top. So that's also another ethyl. And then this is 1, 2, and 3. So this time you have propyl. Prop for 3 carbons. So now we're going to name the branches first. So the ethyl groups, we have 2 of them. And when you have 2 or more identical substituents, you group them with a prefix. So 2 would be di. So that would be 1, 4. Again, the positions are very important. So 1, 4, and then you go ahead and say diethyl. The ethyl comes first because in alphabetical order, you have E before P. So when you have different types of substituents, you arrange them in alphabetical order. So 1,4-diethyl and 4-propyl, and then 6 carbon. The prefix for 6 carbon is hes. So that would be cyclohexane. So 1,4-diethyl, 4-propyl cyclohexane. And that is it. I hope you found this helpful. And don't forget to subscribe to my channel for more videos like this. And thank you so much for watching, and see you in my next video. Bye.